Hey everybody, we're back. We're diving into solving quadratic equations by finding square roots. So today we're going to solve equations by finding square roots. So a couple things you need to remember is, what is a square root? Now keep in mind, if I said find the square root of 9, we know the square root of a number is the number that, when multiplied times itself, is what's called the radicand, which is the number inside the root. So this right here is a radicand. This number 9, okay, is the radicand. And the radical is this part right here, which is the symbol of a root. Okay, so let's jump into a key concept here. Okay, so our key concept here is that a product property, when we have a root of two numbers multiplied by each other, we can split up the roots and multiply them separately. Okay, so for example, the root of 18 is really equivalent to 9 times 2, but we took the root of each, right? And then we know 9, which is really 3, and then the root of 2 stays. And then the quotient property is that the root of a over b can be split up into two separate roots, the root of the top and the root of the bottom. So actually, we're just going to jump into this. We're going to find the properties of square roots, and we're going to simplify the expression. So we're going to simplify the root of 80. Now, we're going to use the product property, and we know 80 can really be written as the root of 10 times the root of 8. Now, here's the deal. When we're looking for these numbers, we want to look for, actually, before we do this, when we're looking for these numbers, we want to look for the most magical roots. So these are kind of like the cute little unicorns in math, right? And those unicorns come from 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, and 12 squared. And those are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Now those numbers all have perfect square roots. So when we're looking for simplifying a square root, we're going to look for which of these numbers in purple here are going to work for us, okay? And then 169. And these magical perfect roots are basically the values of these whole numbers squared. So 9 is 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and so on. But this is basically the box that we kind of want to keep in mind. If I were you, I'd put them in your notes somewhere that you can access them easily, quickly, highlight them, whatever. So basically, we want to see if in this magical number chart, is there anything that can work for 80? So I see, we always start with like the lowest numbers first. I can pull out a 4. So if I pull out 4, the root of 40 and the root of 20 is equivalent to 80. We know the root of 4 is just 2. And this 20 here can also be pulled out into a 4 and 5. So which is also a 2. So we're left with 2 times the root of 5, which is just 4 times the root of 5. Okay. And then let's do the next one. Let's do part B. Part B says the root of 6 times the root of 21. So remember, we're going to use that product property where we can actually multiply them on the inside. So this really becomes 6 times 21, which is really the root of 126. And if I pull out that, I can look at the values. I can see, does 4 go in? No. Does 9 go in? And it actually does. The root of 9 times the root of 14 is 126, which 9 just becomes a whole 3, and the root of 14 can't be simplified. Okay. I'm going to move this down a little bit. Oops. And then let's go ahead and do letter C. We've got the root of 4 over 81. So again, we're going to use that quotient property where we can take something that's all under the root and separate them into their own roots. So we've got the root of 4 on top and the root of 81 on the bottom. So this just becomes 2 on top and 9 on the bottom. And then part D, if we have the root of 7 over 16, I'm going to split them up, 7 over the root of 16. The root of 7 can't be simplified, so it stays, which is fine because it's in the numerator, and you can have roots in the numerator, but you can't have roots in the denominator. So we know the root of 16 is just 4. So again, remember, we cannot have roots in the denominator. So now let's talk about what rationalizing the denominator means. Okay, so just like we talked about, you can only have roots in a numerator, you cannot have them in the denominator, okay? Means rationalizing the denominator makes it so that we're basically eliminating the root in the denominator, okay? So let's say, for example, your denominator looks like root b. You're going to rationalize that by multiplying it by the same thing. Because if I multiply these two, I end up with the root of b squared, which is just b. Okay? Same thing here. If I have a plus b, I'm going to multiply it what's called the conjugate, which the conjugate has the same terms but an opposite sign in the middle. And if I multiply these and FOIL them, we end up with a squared plus the root of ab minus the root of ab, so these cancel, and we end up with minus b, because the root of b times the root of b is just b, okay? Same thing here, if we have a minus the root of b in the denominator, the conjugate of that is going to be the same terms, but the opposite sign. If we multiply those and FOIL them, we end up with a squared minus b again. So we can't have roots in the denominator. So if we have a root in the denominator, we have to rationalize the denominator. So let's practice that, okay? So let's practice part A, where we have the root of 5 over 2. So we're going to use the quotient property, the root of 5 over the root of 2. So the issue is not the numerator, because the numerator, you can have the root, no problem. But the issue is the denominator. So we're going to rationalize it. When it's right here and it's just the root of 2, we're literally going to multiply times itself on top and bottom. Now keep in mind, this root of 2 over 2, remember, root of 2, anything over itself is just 1. So I'm not changing the value. I'm basically just multiplying itself by 1 to get it in the form of what we need. So we've got the top, which we know the root of 5 times the root of 2 is the root of 10 on the top, and the root of 2 times the root of 2, which is the root of 4, which is really just 2. And that's it. All right, let's look at B. We've got 3 over 7 plus the root of 2. So our denominator is in the form of a plus the root of b, or 7 plus the root of 2. So in order to rationalize this, we're going to multiply this by, I'm going to put this in parentheses, we're going to rationalize it by the same terms, but instead of plus, we're going to put a minus in the bottom. And what that does is when we FOIL it, it eliminates that middle term of a root, and it makes it so the roots will cancel. So whatever I multiply to the top, or whatever I multiply to the bottom, I have to multiply to the top, even Steven. And then we're going to distribute and multiply the top and the bottom. So we go 3 times 7 is really 21. Bring over the minus sign. And 3 times the root of 2 is just the 3 root of 2. And then we're going to FOIL the bottom. First, outer, inner, last. So root of 2 times root of 2 is just 2. Okay, now we're going to clean this up a little bit. This is going to cancel here. And we know 49 minus 2 is just 47 on the bottom. And then 21 minus the 3 root of 2 is just, there's nothing you can do with that. You just have to leave it the way it is. So we have 21 minus 3 root of 2. Okay, now here's how to solve a quadratic. Now keep in mind, anytime we solve, we usually have to multiply or subtract over to equal 0. But here's the thing. When we have the only unknown term is x squared, we don't have a middle term for x, so we can directly solve for x squared. And we're going to subtract by 5 to get 3x squared by itself. And we're going to get 36 here when we subtract this. To get x squared by itself, we're going to divide by 3. We get x squared equals 12. And then remember, when we take the square root to solve this, anytime you or I take the square root of something that's not already there, we have to make sure it's plus or minus. So that will cancel here. We get x equals plus or minus the root of 12, which remember, 12, we can pull out a 4 and a 3. And we're left with plus or minus, this 4 becomes a 2, and the root of 3 just stays. So x equals plus or minus 2 times the square root of 3. Okay, so that's how we solve that quadratic equation there. So let's go ahead and practice one more. What if they said simplify? And we're going to simplify -6 over 7 minus the root of 5. So again, this is totally fine the way it is, except for this root in the denominator. So in order to get a root out of the denominator, we have to rationalize. Remember, so we're going to look at the denominator, and because we've got a two-part, right, a two-term value here, we're going to put the same terms, but the opposite sign in the middle. So this was the sign that we had here, minus to start, so we had to multiply it by a plus in the middle. Whatever I multiply on the bottom, I have to multiply identically on the top. I'm going to make some room here. And here we go. So we're going to put parentheses around this and that. We're going to distribute. We get -42 minus 6 root 5 on the top. And then we're going to FOIL this on the bottom. 49 plus 7 root 5 minus 7 root 5 minus the root of 25, which keep in mind that 25 is really just a regular 5. So I'm going to go ahead and just replace it with 5 right now. And then we know this right here is going to cancel positive 7 root 5 and the negative 7 root 5 cancel to 1. And we're left with 49 minus 5, which is 44 in the denominator. And the -42 minus the 6 root of 5 just stays like that. Now, you know what? I almost forgot. One more thing. We have to ask ourselves, can we simplify? And in this case, because this is an even number, this is an even number, this is an even number, we can reduce it all by at least a 2. So if I reduce everything by 2, this is going to be a -21. This will be a -3 root 5. And this will be a 22, which that is now in simplest form. All right, that's all for solving quadratics by finding square roots. I'll see you in class.